Hi and welcome to the 2015 Paper 2 Question 9. This is the third question of Section B and the last question of the paper. 70 marks, so it's going to be a long one. We stuck in the heights of a random sample of 1,000 students were collected and recorded. Take one box from the table below to indicate how you would categorize the type of data collected and explain your choice. So look, you could just guess. If you have no clue what these things mean, I often struggle to remember the difference between them. But if you want a 4 chance of getting it right by guessing, that should get you the low partial. Okay. Obviously, you need to know what these things are, so it's very basic statistics. I often ask students and give it help to or guidance to, do you read the front few pages of the chapter? And invariably, and I mean invariably being never, the student hasn't read it. That's usually the stuff that gives you an understanding of what the hell you're talking about. Okay, what's going on. And it's important to read through them. If you're bored in class, you have a free class, that's as good a study as you'll do leading up to an exam. So let's go through what these different things are now. I have an infographic built in here, and it's a good time to point out, if you want this set of notes to be able to use or print off, whatever, you have the blank space for the answer, the question itself, and then the answer built in on the next page. So just send me an email at shanetroy@gmail.com. That link is on the description of the video. So here we have just data can be broken down into different categorizations. Now we do this in life all the time for everything. We need to try and make sense of the world. We need a way of describing the world. So categorical data now, I often say I call this personally qualitative, okay, and quantitative. Now qualitative data does not have really a number associated with it, okay, whereas quantity, does have a number associated with it. Now I see in a lot of books that's called categorical or numerical, and it's going to split halfway. Some people use both, qualitative, some use categorical, so you kind of need to know both. Now, categorical can be broken into nominal or ordinal, and numerical can be broken down to discrete or continuous. Okay, so you can go through them here. I suggest if this isn't making, or this doesn't make much sense after we've gone through it, look at a video about this, read the beginning of that chapter in your maths book, and one of these things, write it out, draw it out yourself, will help you to make a memory of it, or maybe making some funny mnemonic that is memorable, and you might help to understand what these things are. Okay, so with nominal data, okay, it's not a number, and the order it appears is not important. Okay, so if you do a survey and you're asking whose hair color, it doesn't matter, whose hair color you ask first. Okay, it's not a number. Okay, and if the person has brown hair first, is that better than red hair? No. Okay. So that's nominal data. Now, ordinal data is not a number, but the order of it is important. For example, when you start a school, you're taking, when people start, 10 people, when you start a school, has meaning, okay, has information in it. Now, with the numerical data, or quantitative as I go, discrete data, okay, is a whole number. So, for example, if 10 people got A's in the class, 5 got B's, whatever, okay, that's discrete. It's a definite number. A good example there, the number of sweets in a bag. There'll be 10 sweets, 11 sweets. You can't really get 10 and a half. Now, of course, somebody could break 1 and a half, but let's not be an agent about it. Continuous data here, all values are important. Okay, so basically it can be a decimal. It's the basic way to look at that. So any number that changes over time. So weight, height, age, they're all continuous data. Okay. Now, let's go back to our question and look at it from that context. Tick one box on the table below to indicate how you categorize the type of data collected. So you picked the heights of 1,000 students. So it's a number, so it's not these two. It's numerical. It's discrete. It's not discrete because it's, everybody's not just 5 foot tall. People 5'1", 5'2", 5'3", whatever. So that's changing. So it's continuous. So that's our job. Okay. Now the explanation, I've probably said it a few times, I can go straight to the answer here. The height is a number, and it can be measured, and can be a decimal. So basically, that's the reason it's continuous, not discrete. Okay, it being a number is why it's not nominal, and it's not ordinal. Now that's the second explanation here. There's many ways of explaining this. I said here, just the second explanation, one that came up quite common. It can be any number, can take any number. Okay, so that's part A. Only with 5C, so don't spend too long on it as such. Move on here now to a 20C question. Okay, 0, 10, 17, 20. These are rare, very rare. Okay, and it shows based on the exam that year. This would normally maybe be a 10C question. Okay, so let's read through. So I've added a few things here to help you out. Okay, so I've got the formula here for the mean of a frequency table, a grouped frequency table, and I've got a way to calculate the mean interval height. So there's two types of table or frequency table: ungrouped, okay, where it might be 15 people 145, 60 people 146, whatever. Whereas the grouped frequency table will always have these mid-interval values. Now the reason for it is that if you try to represent the data here in a table and dealt with every single height, 145, 146, 147, 148, the table will be massive. Okay, it'll be unreadable. And the whole point of a table or a graph is to make the data understandable. Okay, so a group frequency table, you do lose something. If I asked, if you said how many people were 146, I don't know looking at this table. I need to go back and look at the raw data. So a group frequency table has disadvantages, but the advantages is readability. So it outweighs it. I can always go back and look at the raw data, assuming I have access to it. Okay. So the sample of 1,000 students were made up of 500 boys and 500 girls. The data from the 500 girls was used to create the information shown in Table 1. Okay. So you have the range of heights here from 145 up as far as 185. You have the different numbers put in there. So it says use the information in Table 1 to estimate the mean height of the girls using mid-interval value. So we can't find it for sure, because we're going to be using, say for this example here, the halfway point is 147.5. So I could be, all of those 15 could be 145, or it could be 150. I don't know. So my kind of estimate there of the mid-interval value is going to make my overall mean not accurate. Okay. The best way to calculate the mean would be with the data itself. Okay, having the exact figures. So I'm sure that'll come up at some stage in this question, asked to explain that. So we'll go to the answer here now. Okay, you'll see, that's just explaining group frequency tables. I'll leave that there for someone using the notes. It's probably very, very small on the screen here, but I have the calculation 147.5 times 15 plus, 152.5, the halfway point here, times 48, plus 157.5 times 80, plus 162.5 times 112, plus 167.5 times 125, plus 172.5 times 81, plus 177.5 times 29, plus the 182.5 times 10. That's all divided by the sum of the frequencies, which is the sum of all these numbers here, which should be 500. That was worth checking it, okay? And I've written it all out here, okay? So I've written out my formula, written out all the calculations. So if I do make an error somewhere along here, it should be able to be found. So my answer should be just one of a number of answers it could be if I make like a little error here. And I should only, not lose too many marks because I have the correct method, just wrong answer. So it's an arithmetic error, or something similar at some stage. Now, it could be compounded by being 2 or 3 of them, in which case, you would be penalized for that. If it was just one error, let's say I took 162.5 and I inverted it and did 126.5, okay, that shouldn't be overly penalized because it's in one sense kind of a misread. And there's so many numbers being put in that happens quite commonly. The reason I'm going on about this so much is if you don't show this calculation, and I often see this, okay, no formula, no workings, just the answer. Now, if you're correct and fully correct, no problem. But if you've made an inverted error once or whatever, and your answer is wrong, all I see is wrong answer, no work shown, 0. 20 marks lost. Okay, it can be very severe. So always show your workings for that reason. Okay, so do the whole calculation. Now you could program this whole thing with the calculator. Okay, might be smarter doing the top and the bottom just because the size of it's a bit unwieldy in terms of numbers for the calculator. So I got 8 T2215 for the top part, the numerator, and the 500 for the denominator of the fraction there. Put them to the calculator, I got 164.43, and it doesn't ask me to round it, but I have put the units in just to make sure I don't get penalized for that. And we're all good. Okay, so move on. Now part 2 here says, what is the largest possible value for the range of the heights of the girl in the sample. I actually mentioned that already, but 145 is the lowest, smallest height. 185 is the highest point. Okay, so the range is the difference between those two numbers. So that should be here, 185, take away 145. The highest possible range is 40. Okay, now in part 3 here, then I'll go back a step. The median height of the girls in the sample is 164.5 centimeters. Explain what this means in the context of the heights of the 500 girls. There's a 5B scale here, okay? And it's going to be very, very hard to explain things. Just take some time, think about the situation. You know, an exam hall can be very, very distracting, okay? But if you think about it, it's very simple, okay? Now, the median is the middle value. I probably made this more complicated here than I need to. But with the median, it's the middle value. So half the girls are shorter, half the girls are taller. That's what I put down here. And that's what it is. Okay, so you can very easily overthink that. And start going, oh, it can't be that. It must be more complicated than that. It's not. Okay. Now we'll move on to part C, part 1 here. Okay, so it says use the data in table 1 to complete table 2 by finding the percentage, so percentage multiplied by 100, of girls in each of the height categories. Now to give an example here, okay, you have your figures from the previous thing. So let's go back here. 112 divided by 500 should be, now let's just remember that. I'll try to pick up my calculator. So 112 divided by 500 gives me 0.224. Multiply that by 100 to change the percentage. I get 22.4. So that's where I've gotten, where they've gotten this 22.4. Okay. So they've done the same thing with the next one. So you have to repeat that for the missing 6 entries. Now, if you've got wrong figures in there, this is why it's a hard one to mark, then, you know, as long as you're right, okay, in terms of with the wrong answer, it'll get marks, full marks for this thing here. So it's a 5C question, so we'll try the answer. I've shown a sample calculation. You don't necessarily need to show all of them. Like once you have one here, you can just go back and replace the number. So I got this by going those. No, that doesn't look necessarily right. Go back here a second. Sorry, it's 15 over 500. So I have done an error there in the sense I got the 3%. I probably put down the wrong sample calculation here. 15, that should be 15 divided by 500 equals 3%. I have to go back and fix that now. So we've done the same thing for basically just changed that 15 for 48, okay, and go by 9.6%, etc., etc. Okay. Now, as long as you can have a sample calculation here, if that's correct, you get something. Okay. Now, part 2 here says use the data in table 2 to draw a histogram showing the percentage of girls in each height category. So we have a blank graph here, and we have a graph here of the boys' height. Okay. So be careful here now. It's in table 2 here. Draw a histogram. Okay. Of the percentage. So which set of data do you take? You take the ones with the 3%, the 9.6, so we just complete it. I graph that there, okay, so that'll be my 3%, the 9.6, and you have your 22.4 up here, whatever it was. Okay, and it has this kind of shape here. Now, if you look at this just from, the data is mostly around the middle. Okay, so you can say that without looking at any more detail, most of the girls are around the same height. Now, you have outliers, okay, you've got short girls, you've got tall girls, but the majority of girls are in the middle. Okay, that's fairly much like the normal distribution of things. That's how life is, okay. Now, different countries can be different things. You know, you make it, say, in Western Europe, a more spread out set of heights. Very tall people, very short people. I lived in Japan for a year, traveling, whatever, and one thing I noticed was that most everybody's around the same height. Okay, you do get tall people, but it's much rarer. You do get really short people, but it's much rarer. Okay, most everybody in the Japanese population was around whatever height the average is. Whereas, so, you know, a more spread out population might look more like this, less like the normal distribution. So one thing to say here about the boys is, yeah, most boys are around the average. That's what the average is. But there's, you know, quite a number of short boys and quite a number of tall boys. Okay. Now, it doesn't mean, I suppose, you can hear some people read this and say, oh, the girls are taller. No, if you look at it, the heights, it's the same heights and the same x value, x-axis. Let's see what they're going to ask for this. So we've got the marks, the 10B marks for the graph there. Make sure that these things join together, and that you get them at the right heights, because each one is looked at individually checked. So part 3 here says, a histogram showing the percentage of boys in each height category is given above. Now, we can't see it all because I'm kind of working on the computer screen here, but we'll flick back and look at it. John examines both histograms and comments that there are roughly twice as many boys as girls in the 175 to 180 centimeters category. Do the histograms support his claim? Okay, so there are roughly twice as many boys as girls in the 175 to 180 cm category. Okay, well, let's see if that's true. Okay, so the 175 to 180 category is this one here, okay, in the girls, and this one here in the boys. Now, there's 2 boxes there in height for the girls. It's about 4 boxes for the boys, so about twice as many boys as girls in the height category. So, does the histogram support his claim? Well, yes, it does. Okay, so you can mention number of boxes. There's 4 boxes for the boys, 2 boxes for the girls, or I just kind of said it in a more general sense. Okay, now part 4 here. Mary comes along and she examines both histograms and comments that I see that there are more tall girls than tall boys. Do the 2 histograms support her claim? Okay, explain your answer. So at least make a guess. Okay, yes or no. 50-50 chance of getting it right. Okay, so let's go back and see. There are more tall girls than tall boys. Now, we know there's the same number of boys and girls in the whole thing. Okay, there are more tall girls, okay, than tall boys. Now, what's tall? This is the highest column. Yeah, that's higher than the boys. But that's representing the number of girls between, what, 160 and 170? Now, is that tall, or is that actually average height? Okay, it's average height. So the tall girls are here, okay? And you can see between 175 and 185. So if we say that, let's take those 2 bars, versus the boys, 175 to 185. Well, it's obvious there's more, those bars are bigger. So there's more boys than girls who are tall, okay? Which is, in a sense, is what you expect from biological difference. But, any 2 populations, that may not be true. So, do the 2 histograms support a claim? No. Okay. The number of boys in the tallest category, you could mention what they are, 175 to 185, of the boys is larger than the equivalent categories in the girls. Okay. Hope that makes sense. It's going to be hard to phrase it. I'm phrasing it with the hindsight of a marking scheme and time to think and write down. You're trying to phrase this in the middle of an exam with all the associated pressures, so I appreciate that. It can be tricky. One way around that is by practicing these questions, you and looking at the marking schemes and looking for the right answer, the way it's phrased in the marking scheme, or from your teacher, whatever. You get more and more used to the kind of way they speak. Okay, so that's part 4. Now part D, part 1 here. I think I've added in this. I'm almost 100% sure I've added in this infographic. I just had to make more sense of this. Okay. Anyway, the mean height of the boys in the sample is 166.7 centimeters, and the standard deviation of their height is 8.9. Assuming that boys' heights are normally distributed, now that's important, okay, this image below that I've put in is of the normal distribution, and if something follows the normal distribution, if you're 1 deviation away from the mean, it covers 68% of the population. If you're 2 standard deviations away from the mean, it covers almost all the population. And if you're 3 standard deviations away from the mean, it covers 99.7% of the population, which is practically everyone. Now, you might have outliers in the population. There's always going to be, if it's just heights, there's always people who are very, very short. And you always have, some dwarfism, maybe. And you always have people suffering from gigantism, okay? Biologically, production of thyroid hormone, whatever. The pituitary, the human growth hormone, okay? So, that's just nature. It'll be statistically insignificant in a sense because there's so few people. Okay, now these are talking about 2 standard deviations, which is between those 2 bars there. So it'll be 95% of the population. Okay. We have to use the empirical rule to find an interval that will contain the heights of approximately 95% of all boys. Now, saying something just about the exam itself, the last 3 years of the paper 2 have been asking for null hypothesis testing and the empirical rule and margin of error. Margin of error formula isn't in the maths tables. It's a section that's not, I would say, all that well covered in certain schools. It's an area I'm not very comfortable with, okay, personally. So it's an area that I would suggest you put more effort into and time into, because it's most likely going to come up every year from now on. So, on a big question like this, question 9. Now, if I keep going, this video's dragging on. Let's show the answer cases. The mean plus or minus 2 standard deviations is the empirical rule, based on the question they've asked. Okay, so that goes 2 standard deviations below the mean and 2 standard deviations above the mean. So it gives us a range here. Now, I probably should have written this as 148. I don't think it'd be penalized for not doing it in the exact format. Okay, and then is less than, greater than your p hat, which is your mean, less than 184.5. It might be a more appropriate way of writing it. The arrow, I think, would definitely get full marks, okay? But I guess sometimes that marks can change, it can be less clear. So you just basically kind of have to, this graph would be in the maths tables, but it'd be in the statistics section, and if you don't really know what it is, by trying to find an exam might not be the best place to start looking, time-wise. But as they said, 1 standard deviation, you'd be taking away 8.9 once and added it once. 2 standard deviations, adding it twice, taking it away twice. If it was 3 standard deviations, adding it 3 times, taking it away 3 times. And you get your range based on what the question asked. That's what I'm trying to get across here. That's D part 1. Now D part 2 says the standard deviation of the heights of the girls in the sample is 7.7 centimeters, while the standard deviation of the heights of the boys is 8.9, as we were given already. So there's a difference. The standard deviation of the boys is higher. Interpret this difference in the context of the data. Now, that kind of question puts the fear of God into me. Okay, it's taken me a long time to really get a handle on standard deviation. It can be one of these things, you kind of get it, and you look back and you forget it a little bit, and you're not sure. But basically, it's how far something deviates from the mean. Okay, so the boys deviate from the mean in a greater way than the girls. So that's one way of looking at it. Or if you had a graph, girls should be more like this, and the boys would be more like, well, more spread out, it's supposed to be. That's terrible. Whatever. It's supposed to be a graph. And that's the kind of idea. That's what it's saying. Okay. Now, actually, I should use this. I forgot I had it in there. So the standard deviation is an indication of how far the data is from the mean. Okay, that's what the standard deviation is. Okay. Therefore, in this scenario, the standard deviation of the boys is larger than the girls. Therefore, the boys' heights vary more than the heights of the girls. Okay. Or you could say the boys' heights are more spread out than the girls, which might be more obvious from the graphs. Now, the graphs we're talking about here are those 2 graphs there. Okay. So the girls is more about the middle, and the boys is more spread out. Hope that makes sense. It is tricky, so if you're not getting it, don't be beating yourself up, okay? Now, that's what the section said, reading the beginning of the chapter. It's very important for, like, getting a handle on these kind of concepts about standard deviation and whatnot. Anyway, that's the end of the 2015 paper 2. Hope I see you in another video. Thank you.